Class, we have discussed about the linear regression, right? So we are discussing about the linear regression and non-linear regression, that is polynomial regression. Okay. The second one we are having is polynomial regression. Now, in the polynomial regression, what we have done is we have increased the degree and we have identified which is the correct degree for the given data by applying the for loop. We have taken some kind of for loop. Inside the for loop only, we have done the modeling. We have done the prediction. We have done the modeling. We have done the prediction and we have done the evaluation. Three of them we have kept inside the for loop only. So every time for each and every degree value, it changes the degree. For each degree, we have done the model, prediction and evaluation. Model, prediction and evaluation and identified which is the best degree. So identifying the degree, the best degree value for polynomial regression. It is called as hyperparameter tuning. Okay. Now what is meant by hyperparameter tuning? Let us take the heading called as hyperparameter tuning. Tuning means identifying the best one. Identify the best value is called as tuning. Parameter means for particular thing. So particular parameter. Here the parameter is hyperparameter. What is meant by hyperparameter means model parameter. As this value changes, the entire model will changes. Example is degree. Degree in polynomial regression. In polynomial regression, one of the example is degree. Okay. So we have identified the best degree value. Indirectly, we have done the tuning only, hyperparameter tuning. Right? Tuning means identifying the best value. Which is the best value means which model value, model parameter. Which model parameter gives the best value. Best value in terms of result. Best value. Identifying the best value in order to get the better results, best results, which gives the best result, right? Example is degree in the polynomial regression. We have changed the degree. So identified which is the best degree for our given data set. Maybe 1, 2, 3, 4, 5, 6. We have identified the best one. So we conclude that the degree is equal to 3 is the best value. Why 3 is the best value? Because that gives the best results. Neither overfitted or underfitted, at the same time high test accuracy. So this parameter, identifying the parameter, is called as tuning. And this is the model parameter. Because this value changes, the model changes. The entire model changes. The number of coefficients changes, everything changes. So it is called as model parameter. Whereas normal parameters like function parameters are normal parameters. Like for example, model.predict on xtrain. In that xtrain word is, inside the predict function, xtrain word is parameter. It is a normal parameter within a function of predict. Right? For example, you are using like MSC. That is mean square error is the function you have imported. Inside that you are going to give you the predicted value, the original value. These two values you are going to give and it is calculating the mean square error. Or for example, if you are giving R square, in the R square, like a model.score. In the model.score, this score is a function. Basically, it is a function. Inside the function, you are going to give the X test and Y test. X test and Y test data you are providing and it is applying the model score. And here these are called as parameters. Just they are called as parameters. They are not called as model parameters. They are not called as hyperparameters. Hyperparameter means model parameter only is called as hyperparameter, which affects the model. These are all the normal functions. They are functions. Within the functions, these are the normal parameters. In the core Python, whatever the functions we have discussed, inside the functions, inside each function we have discussed with respect to the arguments, right? Each argument is called as a parameter. Here, this parameter is called as model parameter. Model parameters are called as hyperparameters. Is that clear? Now, in today's class, we are going to discuss the next concept called as regularization. we are going to discuss the next concept called as regularization. Now, what is this regularization is going to do is just this regularization is going to reduce the model issues, like the minimizing the model complexity. Now, what is meant by model complexity? First, let us understand what is meant by model complexity. For example, more number of values are there. What values? Coefficients. For the linear regression, beta naught plus beta 1 x1 plus beta 2 x2 plus, like this you are having. For example, if you go for degree of 1 means 3 of them only we are having. Beta 1, beta 2, beta 3. That is TV, radio, newspaper. If you go with the degree of 2 means we are having 9 coefficients. Because x1 square, x2 square, x3 square, x1, x2, x2, x3, x3, x1. So 9 coefficients we are having overall. Now, if you go with a degree of 3 means 19 coefficients we are getting. If you go with a degree of 4 means more number of coefficients. Still the number of coefficients automatically increases. As you increase the degree, the number of coefficient increases. If the number of coefficient increases, what happens? It is going to lead to the complex. Because we have to require these many values to predict the answer. The equation is going to become the complex equation. So, in order to minimize the model complexity means reducing the number of coefficient values. Okay. And we are penalizing the loss function. Now, what is meant by loss function means error. Whatever the error we are considering, that is RMSC, root mean square error, or with respect to MSC, whatever the error you are calculating, that error is called as loss function. Your error is called as loss function. So, penalizing the loss function means penalizing the error. Penalizing the error means nothing but reducing the error. Penalizing means reducing. Right? So, here in this regularization, we are going to reduce the model complexity. We are going to reduce the error. It is going to reduce the overfitting problem. So, these are the few things it is going to solve. It may solve all of them. It might reduce the complexity. Some cases, it may not reduce the complexity. For example, let us take like this. TV, radio, newspaper. 3 values are there. Now, beta naught plus beta 1 x1 plus beta 2 x2 plus beta 3 x3. Okay. Now, by adding this regularization, now what I am going to do is one of the parameter, which is unimportant parameter, we may drop. That is beta 1 x1 plus beta 2 x2 only. So, it has reduced the number of coefficients. Here, the model complexity has reduced. In some cases, it may not reduce the model complexity. In some cases, what it does means, it helps in terms of either reducing the overfitting problem. Out of these 3, any one will happen or all of them will happen. It is not mandatory that everything should happen. There is no rule like that. Okay. It will try with respect to this one or this one or this one or any 2 or any 3. Anything can happen. Right? So, here it is going to reduce the model overfitting by adding the more bias. So, if you consider I have told you earlier, the weighing machine is there. Let us take a weighing machine where instead of considering an electronic weighing machine, let us go with a normal weighing machine, manual weighing machine, where one side will be having some kind of stones related to 1 kg, 2 kg or whatever it is. And the side will have the product, whatever the product we are purchasing. Now, here, the difference between both of them. For example, I have kept this side 1 kg stone. And here the product is of just 800 grams is there. Or 600 grams is there. Just assume 600 only is there. Now, one side 1000 grams is there. One side 600 only is there. 1 kg stone means equal to 1000 grams. And the side 600 only is there. Now, one way of balancing that one is with respect to how to balance by adding this 400 grams to this. If the person requirement is 1000 grams means we'll add the 400. If the client requirement is normal, the person requirement is anything is okay means just we are going to reduce this one only to 600 grams and we are going to finalize and we'll close. We'll sell this product for 600 grams only. We'll sell the product. For example, let us take in this way. I want to purchase 1 kg of apples. Okay, 1 kg apples. Okay. 1 kg apples I want to purchase. And I have selected around 6 pieces. So I have selected 6 pieces, 6 apple pieces I have selected. Now, if I weigh this one, if I check the weighing of these 6 pieces, the 6 pieces is around 1.4 kgs. Now the person is going to remove one of the piece and he is going to level to both of them to 1 kg, either one way. If I say that, no, I require all the 6 pieces, you only increase the weight and you tell me what is the weight, miss, he will say, sir, this is having 1.4 kgs, pay for that accordingly. Right? Either of. If you require 1 kg, miss, he will remove the pieces and he will give the apples. And if you want this all the 6 pieces, miss, he will add the stones and he will say that, sir, it is of 1.4 kgs and he will give us. Now here, the one option is with respect to this increasing the product value, miss, another way is this one. So here what I'm going to do is, in order to reduce the model variance, I am doing the bias, I'm increasing. Another side, I'm increasing the value. We are having one side bias, left side bias and variance, two are there. In order to reduce this one, what I'm going to do is, I'm increasing this one. Right? For example, here 1.4 kg, whatever the example I have told you, here I am having only 1 kg, means I am adding remaining 400 grams this side and I am bringing this one to 1.4 kg. So that I want to balance both of them. Another side, I am increasing one more, which is called as bias. So for reducing the overfitting problem, I am going to increase the bias. Right? So here, the way to reduce the overfitting problem, requires some additional bias, which can be done by using the hyperparameter. We are going to optimize this one by applying the hyperparameter tuning. So here in the regularization, we are having 3 types of regularization. One is called as lasso regression. Second one is called as ridge regression. And third one is called as elastic net regression, which is a combination of L1 and L2. We should not say L3. There is no name called as L3. Just it is a combination of L1 plus L2. Right? Now, let us start with respect to understanding one by one. Okay. Now, first let us start with L2. Okay. We actually cover first L2 because it is easy to understand, or with respect to the concept. So, ridge regression advantage is to avoid overfitting. Whether it is a ridge or whether it is a lasso, both of them, the advantage is to reduce the overfitting. Our ultimate goal is the one that could generalize the patterns, works best on the training and test data set. It should work both on the test data and train data. It should not work only on the train data. It should not work only on the test data. It should work on both the scenarios. Overfitting occurs when the trained model performs well. Performs well means training is very good. And training data and performance poorly on the testing data. Means performing well means the meaning is train accuracy is high. Train accuracy is high. Test accuracy is low. Then it is called as overfitting problem. So now overfitting occurs when we are having test accuracy very high value and train accuracy very high value, test accuracy low. Then at that time we are having the overfitting problem. Now ridge regression will work by penalizing this one in order to reduce the overfitting. Now, if you observe this one, there is a red data point. Some data points are there on the graph. Some scatter plot is there. Red data points are there. Now, for this red data points, if you go with this kind of line, if you consider this line is having for each data point some error is there, which is very good with respect to training and testing. But if you go with this dark blue color line, what happened? It is going to include all the data points. Now, what happened in this case? The curve was overfitted. So now in this case, what is the error? Predicted answer will be the same. Original answer also will be the same. Error is going to be 0. If the error is 0, accuracy is going to be 100%. Now in this case, what happens? If it is passing through each and every data point like this, automatically it is going to lead to the overfitting problem. Now, so let us take an example. Where you are having only 3 data points. Only these 3 data points are there for training purpose. Now, if you are applying the least squares method, you are simply drawing a straight line over this one. Least square method. Directly least square method means nothing but linear regression. Just you are applying a normal linear regression and it is passing through all the training data points. Since it is passing through the training data points, the sum of the errors is equal to 0. Now this is the test data. This line was selected based only on the train data. It is not selected based on the test data. Whatever the train data you have given, according to that I am doing. In the test, whatever it is there, it is just ignoring. It is just working only on the train data. However, the testing data, the sum of the residuals is very high. Means the errors are very high. If you consider the same line, the errors are getting very high. Now here, variance means there is a difference in the fit between the train accuracy and test accuracy. That is the difference between the errors. Now I want, with respect to the new equation, how I am going to create a new equation means like this. So now what happened in this case? Train accuracy also reduced. In the earlier example, just focus on this example clearly. In the earlier example, the green data points are train data points. Green data points are train data points, and the line was passed through all the green data points, and the sum of the squares of errors is equal to 0, which means train accuracy is equal to 100% in this case. Forget about the test data that we'll discuss later. First focus only on the train data, green points. Now, what I'm going to do is, I'm going to change this one. The line I'm going to change. Now what happened? Now I'm going to get SSC is equal to some value I'm going to get. It is not going to be 0 because I'm going to get the error. Since there is an error, now the train accuracy is going to be reduced. Assume it has reduced to 85% or 95%. 95%, 5% you are reducing the train accuracy. Voluntarily you are doing that one. Actually it can give the 100% train data also. Still you are only trying to give for respect to 95%. You are voluntarily reducing the accuracy of train accuracy. Now if you observe this one, in the case 1, train accuracy completed. Train accuracy is, what is the train accuracy for this one? 100%. What is the test accuracy now? More error will be there. Assume the error is approximately 60% accuracy you are having in this case. Now what happened in the case 2, Case 2, you are trying to reduce the error of this one. Means in the train accuracy, you are trying to increase the error and reduce the train accuracy. Now what happens? The accuracy was dropped. The accuracy you are bringing to 90% and another side you are trying to bring to 80%. So in order to balance that one. Got the point? Sir, now your question will be, sir, here already train accuracy 100% is there. Means why we have to reduce the train accuracy? Why we have to reduce the train accuracy? Because if you observe this line, it is having more deviation in the test data. Now in the second line, it is having less deviation in the test data. In the testing also, it should have the less. Our ultimate goal is not with respect to train data. Our ultimate goal is both train and test. Simultaneously, we have to get. Simultaneously, we have to do. For example, let us take like this. In the polynomial regression, I have explained you what is meant by polynomial regression and I have shown you for loop and how to identify the degree. Now, if you go with the random state or if you go with the train test split, or yesterday I have explained some of the concepts, but that concepts code I have not shown in the class. Do you remember? In the yesterday's class, whatever we have discussed, that code I have not shown in the class. Now, if I show that code also in the class, what happens? If I do that one also in the class, what happens? That one also, everything if I do spoon feeded, every letter to letter if I spoon feed, you will understand very clearly and your train accuracy will be 100%. But tomorrow, once you go to the industry, if they give suddenly, if they ask you to do something, miss, just orally they will say something and they ask you to do. No, sir, you are saying orally, sir. Don't say orally, sir. Show the Python code, sir. Whatever the code you show, I will copy only, sir. We can't say like this, right? Getting the point? So, if I train you in such a way that each and every data, each and every single, whatever I'm explaining orally also, if I show that one in the Python code, then it is going to lead to the overfitting problem. That is the reason I will not do like that. Some things I will explain orally. I will ask you only to do that one. If I do that one in the class, what happens? Only for loop only I have to write for loop and identify the random state, best random state number. How much time it will take for me? 5 minutes or 10 minutes. If I write the code in my home and if I bring outside, it will take just 2 minutes to show you. But what happens at the end is it is going to lead to the overfitting problem. Right? So when I'm discussing orally, you have to do this way, this way, this way. If I say something this way, you do and practice like this means you have to do on your own. That one also, if you ask, sir, you have explained, but I'm not able to understand, please share the code for that one also, miss. That lead to the overfitting. In the company, they will say orally only. They will not say the Python code. They will not give the Python code. Oh, go and buy her this one. I will ask the interview questions. They will not say like this, right? Getting the point? So similarly here, I want the test accuracy and train accuracy. I have to focus on both of them. I don't want to focus only on the train accuracy. I'm focusing on the both of them. So ridge regression works by attempting the increase in bias. Increasing bias means in order to bias increases, what happens when you are increasing high bias, low variance. What is that model? So you are going to try to increase the bias. Whenever you are trying to increase the high bias, whatever happens, slowly it reduces the value. Still more, if you increase, then underfitting problem will come. Too much of high bias is also underfitting problem. So slightly you are increasing the bias so that the variance will be reduced. The difference, variance means nothing but difference. You are trying to reduce the difference between train accuracy and test accuracy. Is that clear? So now here that bias is nothing but alpha into slope square. Nothing but alpha into slope square. Just in order to understand ridge regression, very simple. First, linear regression. What is meant by linear regression? Linear regression means which is passing linearly. That is basic. What is the method in that? Ordinary least squares method. What is meant by ordinary least square method? Sum of the squares of error should be minimum. That is sigma of y minus y hat whole square should be minimum. This value, whatever the value is there, this should be minimum. Right? That is sum of the squares of errors. That is SSC. Whatever the SSC is there, that SSC should be minimum. Now, y is equal to beta naught plus beta 1 x. Assume we are having only single variable x. Now, let us take a data set where I'm having a single variable x and single variable y. Only single variable. This is called as linear regression model. We have to identify for linear regression such a way of beta and beta 1. We have to identify these two values. We have to identify these two values, which gives the sum of the squares of errors as minimum. We can't select as per our choice of beta and beta naught and beta 1. Beta naught and beta 1 was selected such a way that the sum of the squares of errors is minimum. The same thing in ridge regression. What happens means beta naught plus beta 1 x plus alpha into beta square. Whatever the beta square, that is slope square is there. This one, overall this one should be minimum. You have to identify your in the beta naught plus beta 1 x. You are going to identify beta 1 x only. Beta naught and beta 1 x only you are going to identify. Once again, you are going to identify these two values only. But this time you are not going to focus only on the SSC. Plus alpha into beta square also should be less. What is meant by alpha into beta square means beta 1 square. Beta 1 is nothing but this one. Is that clear? This value should be minimum. This value should be minimum. We have to identify in such a way that the sum of the squares of errors plus alpha into beta 1 into slope square. Sir, can you explain detailedly? Let us take x and y. 1, 2, 3, 4, 5. This one 11, 14, 16, 20, 19. Something we are having like this, some values. Okay, randomly I have written. Now, earlier whatever we have done is, we have identified our beta and beta 1, beta naught and beta 1 based on the SSC minimum. For example, let us take an example of beta naught and beta 1. I will take the beta naught as 5 and beta 1 as 2x. And second one, 5.4 plus 2.8x. Third one, 5.2 plus 2.2x. Fourth one, 5.9 plus 1.4x. Out of all these things, which equation is the best one? Let us assume these are the 4 equations. Only 4 are there. Out of these 4, tell me which is the best one for the given data. How to identify that one? Which gives the sum of the squares of errors as minimum. Right? So just you are going to substitute your x values in this case, and you are going to calculate the y hat, and you are going to calculate that is y minus y hat whole square. And for first equation, you will calculate y minus y hat whole square formula, and you will calculate SSC. Second one, you will calculate SSC. Third one, you will calculate SSC. Fourth one, you will calculate SSC. Out of these 4, whichever is minimum is there, that one you are going to select. Assume these are the 4 equations. Now in ridge regression, what happens means you have to select the equation y hat. Okay, just substitute this x value here. You have to calculate in such a way that whatever the, after substituting the x value, you are going to get y hat values. Now you have to do the y minus y hat whole square formula. This one keep the side. And along with that, alpha into beta 1 square. Beta 1 square means 4 into x. Beta square, that is 4 square. That is 4 square is nothing but, sorry, 2 square. 2 square is nothing but 4. So alpha, this one plus 4 alpha, or it should be minimum. Got the point? Is that clear? So in the linear regression, just you are calculating. For example, let us take like this. First, take the y hat is equal to 5 plus 2x. Let us do that one. Manual calculation. Now you'll understand easily. Okay. 5 plus 2x. X is equal to 1. Substitute x is equal to 1. 5 plus 2. What is the value? 7. X is equal to 2. 5 plus 9. Next one. 11, 13, 15. Now, what is the y minus y hat? 4, 5, 5, 7, 4. Now, y minus y hat whole square. Y minus y hat whole square is nothing but 16, 25, 25, 49, and 16. Calculate total, that is 50, 66, 75, 115, 121, 131. Right? Approximately 131. Let us keep this one side. For which equation? Equation number called as 5 plus 2x. SSC is equal to 131. Now, 5.4 plus, instead of 5.4, let us take a simple one. 6 plus 3x. Let us take 2 equations. Or just 2 equations. Second equation as 5 plus 6 plus 3x. Now tell me, what is the y hat values, and what is this one, and what is this one? 6 plus 3x is the equation. First value is going to be 9, 12, 15, 18, and 21. Right? That's it. Now, errors are with respect to 2, 2, 1, 2, 2. That is, anyways, we are minus or plus, we are going to do square only, na? 4, 4, 1, 4, 4. The total is 70. SSC for this one is 131, for this is 70. This is a normal linear regression. We have applied a normal linear regression, and out of these 2, this is the best equation for the given data. We are deciding. Now, if you are going with the ridge regression, the SSC plus alpha into slope square. This value should be minimum. You fix some value of alpha. Choice is yours. Take any value of alpha as per your choice, any number. Let us assume alpha is equal to 2. If alpha is equal to 2, for case 1, 131 plus 2 into, what is this one? 2 square, which is nothing but 131 plus 8, 139. Now, in this case, 17 plus 2 into 3 square, that is 3 square is 9, 9 plus 9 into 2, 18, 18 plus 17, 35. Now this, out of these two, which is the least one? That one you have to select. That is the difference between here. Just here you are going to check only SSC. Here you are going to check total. Doing this one you are going to check and identifying which is the best one. Here you are identifying just by applying the SSC only. Just you are identifying which is the least. But here SSC plus alpha into slope square also should be minimum. Overall it should be minimum. Got the point? Whatever this is called as penalty term. Penalty term, which is nothing but which is increasing the bias. Which you are adding the bias. This is the bias term. Now overall it should be minimum. Which equation gives overall minimum, that one you are going to select. In my case, the equation of this one and equation of this one both are satisfying. For my example, it is satisfying. For some examples, it might be, both of them will not be the same. For example, let us take in your example 5.4 plus 2.8x, 5.5 plus 2.85x. Try after going to home, try for these two equations. For linear equation, which is the best one? For ridge regression, which is the best one? You tell me. For the same data set is same. For the same data set, try these two equations after going to home. Then you'll identify the difference easily. Right? So here whatever the least square method says that just we require the sum of the squares of errors should be minimum. Whereas ridge regression says that sum of the squares of residuals plus alpha into slope square. If single one x variable is there, one x and one y is there, means we are going to do alpha into beta 1 square. If two variables are there, x1, x2 and y, then alpha into beta 1 square plus beta 2 square. That is nothing but alpha into sum of slope square. Sigma of slope square. That is the penalty term. Right? Now adding by this penalty, what happens is the equation will shift like this. The line will be shifted in this way. Right? Now, L2 regulations add a penalty equal to the square of the magnitude of the coefficients. And all the coefficients are shrunk by the same factor, because here whatever the slope squares you are considering, that is beta 1 square plus beta 2 square plus beta 3 square. Assume that TV, radio, newspaper example only. So we are having three values. For that, we are going to multiply with alpha. Means all the beta values are shrunk by the alpha, means reduced by alpha. Whether it is multiplied, if it is 0.1 means reduced. If it is 2 times means multiplied, whatever it is. Right? So here, the values, whatever the alpha values are there, all the coefficients are shrunk by the same factor, because you are multiplying everything with alpha only. Doesn't necessarily eliminate the coefficients. In the ridge regression, it will not eliminate the coefficients. As the alpha value increases, the slope of the regression line is reduced and becomes more horizontal. If you go with like this, as alpha increases from 0, alpha is equal to 1, alpha is equal to 3, alpha is equal to 10. If you increases the alpha, as the alpha increases, the model becomes less sensitive to the variations. Means it is going to become the horizontal line. When it becomes the horizontal line, then average line will be the best fit line. Then no need of regression also to apply. Right? As the alpha increases, the overall slope reduces. Right? Now coming to the lasso, the only difference between ridge and lasso is alpha into modulus of slope. Alpha into modulus of slope. That is the only difference between both of them. One is alpha into slope square, one is modulus of slope. And here, the most important term is the effect of alpha on lasso regression is similar to ridge regression. As the alpha increases, it is going to be horizontal. Once the line was horizontal, there will be no variations in the x. Now, here the most important point is lasso regression helps to reduce the overfitting problem. And particularly it is used for future selection. This word is more important. particularly lasso is used for future selection. What is meant by how it is identifying the future selection, you know? Where ridge regression can reduce the slope close to zero. Slope close to zero means beta naught plus beta 1 value. It will bring, if the value is not important, means it will bring to 0.006 like this. It will reduce. But whereas lasso directly will bring the whichever unimportant variables are there, that quotient values will become as 0. If the quotient value is 0 means, for example, let us assume we have applied for the TV, radio, newspaper, advertisement, that one only, radio and newspaper. Now, assume that I have applied the lasso. After applying the lasso, I have checked the beta 2 is equal to 0. What is the meaning of beta 2 is equal to 0 means this variable is there also, not there also, same issue. Because if you multiply, whatever the value you multiply, it is going to be 0 only. It is going to make the slope is equal to 0 means indirectly it is terminating the variable. It is removing that variable. So it is going to be useful in the future selection. So future selection, how we can identify which features are important and which features are not important means by seeing the whichever the quotient is equal to 0, that features are unimportant variables. We can remove those variables after applying the lasso regression. So lasso regression can be useful if we are having several independent variables that are useless. Independent variables means several x1, x2, x3. Independent variables means x variables. Several independent variables which we are having, which are useless. So useless variables automatically it will come to 0. All the useless variables will come to 0. For example, I want to predict the salary of a person, salary of a data scientist. For that, I require the skill set of the person. I require with respect to the number of projects, how many projects are done. Now assume there is a column name called as name of the person. Name of the person and salary, is there any relation is there? So automatically lasso will identify that one and it makes this particular quotient to 0. Whenever the quotient is 0 means this particular variable is not useful and we are going to remove that one. We'll drop. df.drop function will apply and we'll remove that particular variable and again we'll refit the model. In this way, we are going to identify which are the important parameters. For example, let us take an example like this. Personal loan. Okay. How many of them knows that about the personal loans? How many have taken till now any loan, education loan or personal loan or whatever it is? How many? Just 1 or 2. Okay, fine. Now, whenever we are working on the loan data, now that when, for example, I have went for a bank and I am asking for a loan, particular loan, there is going to be an application form. In the application form, name of the person will be there. Common, right? Name of the applicant is first one, common. Second one, father name, mother name, date of birth, and nationality, Indian or whatever it is. Next, address, your present address or permanent address. It is going to ask both present address and permanent address. Next, office address. Next, pay slip. Whatever the pay slip, and I mean salary. You are saying that I am getting 1 lakh rupees salary and I want to have a loan of 10 lakhs means they have to believe means first you have to show the pay slip. So pay slips, they are going to ask the pay slips like Aadhaar card, PAN card, all these details they are going to collect from us. Now, after collecting all these details, now they are going to predict whether for this person we can give the loan or not. The bank people are going to check whether we can give the loan or not for this particular person. Now, what happens whenever we have filled the form and all these things, out of which for giving the loan is my name is important. If my name is Sivaram Krishna means I will not get the loan. If my name is Mahesh Babu means I will get the loan. No, right? There is no requirement. No, there is nothing based on the name. If my father name is with respect to different name also, there is no relation to give with respect to approve the loan or to reject the loan. There is no relation with mother name, father name. There is no relation with respect date of birth. Date of birth is important where they are going to calculate the age. From this, they are going to create a new future. The actual future they are going to collect from us is date of birth. From that, they are going to collect the age parameter. And based on the age, they are going to check the relation. So now, whichever the Futures are having a good correlation, that one they are going to consider. Whichever the futures are not having a good correlation, that one will be dropped during the prediction. Right? So in order, so for that reason, we required with respect to this future selection is important. Future selection means which futures are important. For getting the data science job, number of projects are important. Whatever the certification you have done is important. Your Kaggle rank is important. But your body weight is not important. Your height is not important. Your name is not important. How many classes you attended in Naresh is not important. How many hours you have seen the whiteboard is not important. These all are not important. Right? These futures are not important. Only the futures are number of projects, how many you have done. Based on the subject, whatever you have learned, from that, how many projects you have done. And what is your Kaggle rank or what is your certifications. Right? This all says that how much subject you are having. Right? So, future selection means identifying the important futures. So, lasso is going to be with respect to it identifies the important futures. But ridge regression cannot do that one. Ridge regression only can bring if it is a unimportant variable. Though it is an important variable, just it will bring to 0.00001. Some value will be there. It will reduce the value, but not 0. But whereas lasso directly will bring to 0. It will say directly it is 0. That is the difference. Okay. Whereas ridge regression can reduce the coefficient values. Slope means nothing but coefficient values. The coefficient values close to 0. Whereas lasso will bring the slope directly exactly equal to 0, whichever is unimportant variable. So when in the lasso regression, if you have identified that particular variable is equal to 0, that particular coefficient is equal to 0 means that particular variable you don't need to consider for the prediction purpose in the future. Okay. So L1 regressions add a penalty equal to the absolute value of the magnitude of the coefficients. That is the difference between lasso and ridge. So normal linear regression is just the sum of the squares of residuals. That is SSC. Sum of the squares of errors should be minimum for our case, OLS technique. Whereas ridge regression is OLS plus alpha into slope square. Overall, it should be minimum. SSC plus alpha into slope square should be minimum. Whereas lasso, SSC plus alpha into modulus of slope should be minimum. This value, whichever the minimum value is that is the best fit line. It will consider in that way. Now here, slope means, coefficient value. Now what is meant by alpha? Alpha is not fixed. We have to identify that one. That is the hyperparameter. We have to change for the different values. That is not fixed value. So we are going to change for different values and we are going to identify which is the best one. Right? Next one is elastic net. Elastic net is both combination of L1 and L2. It is a combination of L1 and L2. For example, you have select this. It is going to depend on the lambda parameter. What is meant by lambda means lambda is equal to L1 ratio. L1 ratio means nothing but lambda is equal to how much percentage of L1 divided by L2 you want to consider. If lambda is equal to 0, what is the meaning of that means? You are considering just only the lasso regression. If lambda is equal to 0 means just you are considering the lasso regression. If the lambda is equal to 1, means you are considering with respect, this is 1 means this is 0. If this is 1, this part will become 0. Then you are going to consider the lasso. So, whenever you are working on the lambda is equal to 0, automatically this is 1 minus 0, that is 1. 1 into ridge regression. Whatever the ridge regression you are having, ridge regression, and lasso is become the 0. Okay, lasso becomes the 0. When lambda is equal to 0, lasso is equal to 0. When lambda is equal to 1, okay, when lambda is equal to 1, in that case, ridge is 0 and we are going to have the lasso. So here the lambda value will be between, the lambda should be between 0 to 1. If it is exactly 0 means it is called as ridge regression. If it is exactly 1 means it is called as lasso regression. Lambda is equal to 0 means lasso becomes 0. Lasso becomes 0 means that is equal to ridge regression. Both are same. Just substitute the lambda is equal to 0 here. Lambda is equal to 0 means this part is not there. This part only. What is this part? Sum of the squares of residuals, that is SSC plus alpha into slope square. What is the meaning of this one? Which is nothing but ridge regression. If the lambda is equal to 0, this is nothing but ridge regression. If lambda is equal to 1, it is nothing but lasso regression. Lambda value should be between 0 to 1. So now here alpha I don't know, lambda I don't know. Both of them I don't know. We have to apply different values. We have to try with the different values. Sir, how we for one of them is for loop? Okay, sir. We are applying the for loop. For I in alpha, or for I in whatever the values, we are going to consider the different alpha values. For different alpha values, we are going to do. But lambda value, then what we have to do is nested for loop. For first for loop is for alpha, second for loop is for lambda. It is going to take both the combinations, different combinations it is going to apply, and finally it will identify which is the best one. Right? So now whatever the alpha value is there, what would be the range of alpha values and what would be the range of lambda values? The range of lambda values should be between 0 to 1. Lambda should be between 0 to 1. The range of lambda should be between 0 to 1, where 0 is included, 1 also included. Okay. Whereas alpha, there is no rule like that. You have to consider this one only. So we'll try for different values. Now, let us start the coding part. The same thing, whatever I have explained now, lasso, ridge, and this one. So now, once again, I'm going to take the same advertising data set. From the first day, whatever the project I have started is same advertising data set, TV, radio, newspaper. I have applied the multiple linear regression. I have applied the polynomial regression. Simple, we can't apply on this because it is a multiple. TV, radio, newspaper, 3 of them you have to consider means minimum starts with multiple linear regression. So multiple linear regression I have applied. Polynomial regression I have applied. Now I am going to apply lasso, ridge, and elastic net on the same data. Same data set I am going to apply all of them. And finally out of all of the models, which is the best model that I am going to finalize. So this one I have explained in one of the class, completed. This I have explained in one of the class. So now I'm going to identify with the lasso, ridge, and elastic net. And out of all these 5 models, which is the best model that I'm going to conclude. Right? So here, let us start with respect. First, import the libraries and your data set and info, the same. And exploratory data analysis, you are doing the same. X and Y, you are going to take the same. Train test split also, test size of 0.3, random set of 42. The same thing what I have considered in the multiple linear regression, same data set. I have not changed the data set. Now, just what I'm going to do is, first I'm going to apply the lasso regression, modeling with default parameters. What is meant by default parameters means, it is going to consider by default, the alpha value is equal to 1. I'm not going to change the alpha value. Whatever the default is there, I'm leaving first default value. And I'm fitting the first sklearn.linear model import lasso. And I'm going to save the model. And I'm going to fit on the X train, Y train. And I'm going to calculate the intercept value and quotient values. Followed by, I'm going to predict on the X train, Y train, X train separately. And I'm going to save that one. I'm going to predict on the X test. I'm going to save that one. Evaluation, I'm going to do the train R square, test R square, and CV value. The same thing, right? Is there any question in this? Just I have copied everything in the single cell. Instead of writing in the multiple cells, I have written in the single cell, where the modeling, prediction, and evaluation. This model is called as lasso with default parameter. Default alpha is equal to 0. Sorry, what is alpha? 1. Alpha is equal to 1 by considering alpha is equal to 1. Now, For alpha is equal to 1, I have got these quotients. The values are like this. Train R square is equal to 90%. Test R square is 86%. And CV value is 88%. With alpha is equal to 1 default. Now what I want to do, I want to try for different alpha values. Alpha is equal to 1 is the default value. For default value, instead of default value, now I'm going to change to 2. And I'm going to change to 3. And I will change with respect to 0.5, 0.2. Like this, I'm going to try. I'm going to check. Now what I'm going to change, only the alpha value I'm changing. This I'm going to keep as I, and I'm applying the for loop. For I in whatever the things you want to identify. First you list, take a list that is 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 1, 15, 25. You have given a list like this. Now for I in list, it is going to take first I value is equal to 0.1 and it will execute. I is equal to 0.2, it will execute. I is equal to 0.3, it will execute. I is equal to 0.5, it will execute. I is equal to this one, it will execute. Like this, it is going to execute whatever the parameter, whatever the values you have given, it will execute all of them. And within this, which is the best one, you have to identify. For that, what we have to do? We have to take the for loop. So by adding the for loop, along with that, we have to take the train R square is equal to empties and test R square is equal to empty list, and we have to append. Every time for each alpha value, we have to append. And after appending each alpha value, we have to identify which is the best one. Right? This we have done in the last class in the polynomial regression. Now for that, there is a shortcut called as grid search CV. You don't need to apply the for loop. Automatically, it will only apply the for loop. That is the shortcut called as grid search CV. Grid, write in your notes very clearly. Most means dead most. Sorry, ultra most. Not ultra, platinum most. Okay. That much of important concept in entire machine learning. Grid search CV. What is meant by search means? It is going to identify. Search means nothing but identify. Okay. Identify the best parameter. Best parameter value. Identify the best parameter value. Grid means in the given data. Grid is nothing but in the given. In the given values, within the given values. Within the given values, it will identify the best parameter value, which gives the best CV. That is the meaning of grid search CV. Got the point? Now, so here, how to apply the grid search CV means from sklearn.model selection, import the grid search CV. This is the function. Okay, we have to import the grid search CV. Grid search CV. Within this grid search CV, first one, we have to write the estimator. What is meant by estimator means nothing but for which model you want to do. That is the estimator. 2. Second, we have to give, second parameter is called as param grid. Param grid is nothing but estimator. Estimator nothing but model. Param grid is nothing but a grid of values for which it has to check. Grid of values for which it has to check. And CV is equal to 5. We are going to give some CV value 5. Right? Now by applying this one, now what happens? So for example, let us take like this. Okay, you are writing, right? Estimator means model, grid of values means it is going to check for which it has to do all these things. Okay. So now I'm going to take like this. Grid search. Don't write. Now don't write. Just focus. Grid search CV. I'm going to write the estimator is equal to lasso model. Okay. Lasso model. Grid is param grid. Param grid. Param grid is equal to, I'm going to take a dictionary. 100% it should be a dictionary only. Inside the dictionary, I'm going to take alpha as the key and list of values. One, I'm going to take the list of values as 0.1, 0.2, 0.3, 0.4, 0.5, 1, 10, 100, something I have taken like this. Okay. Now, this is the lasso param grid I have written like this. And I'm now applying this grid search CV, whatever the grid search CV dot fit on X train, Y train. I'm going to write the code like this. This is called as Python code. Now, what happens when you have written like this? What happens in the backend? Just it is going to take for I in whatever the list you have provided here, it is going to take it as a list. This is going to be saved as a temporary variable called as L. And it is going to take inside model is equal to lasso alpha is equal to I value. And this model, it is going to fit on the X train, Y train. And it will calculate the CV. And whatever the CV is there, this CV will be appended into an empty list. Whatever the CV, every time you are going to get the CV, average CV is there, right? Yeah, CV score, directly CV score. Whatever the CV score is there, this CV score will be appended. In the backend, this is going to do this one. Is that clear? Instead of writing manually the code like this for loop, if you write normally also the same answer, both are same only. Just here, whatever the key name is there, that it is going to take inside this value. Inside the model parameter, whatever the model parameter, this one and this one should be the same. And for different values, what values I have to check, for which values I have to check, that values are these values. Now it is going to apply the for loop and it is going to identify which is the best one. Generally, what we have to do is, for this generally, we have to write the for loop. We have to write the CV is equal to empty and we have to fit on the X train, Y train. And every time we have to append whatever the CV we have got, we have to append this CV dot append of whatever the value is there. We have to do the append function. And after appending, once the CV, the list of CV is there, within that, which is the best one we have to identify. Means nothing but CV dot sort function we have to apply. Once we apply the sort function, we are going to get the, which is the highest value. While writing ascending is equal to false. We are writing ascending is equal to false means descending order. So whenever we are having in the descending order, the first portion will be the maximum value. For the first portion, which value has given the first portion the maximum value? That index number we are going to identify. And after identifying this index number, next will come out of that one. Instead of writing these much of things manually, we are just writing the grid search CV. Automatically it will only do. So just if you observe here, estimator is equal to lasso, alpha values 0.1, 0.2. For which one you want to check? For which one you want to check, that you have to mention here. And now whenever you have written this alpha values like this, that is param grid and estimator, both of them you have written like this. Now the grid set CV, estimator means lasso, param grid means this one. And CV is equal to 5. It is going to apply CV and it will identify which is the best square. Identifies out of all of them which is the best square for the given train data. So it is identifying alpha is equal to 1000 is the best one. It has checked for alpha is equal to 0.1, checked for alpha is equal to 0.2. First model, you have done the first model of lasso. Lasso first model, alpha is equal to 1. That is your first model. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now you are going to try with different 9 alpha values and you are going to use the same thing, right? So now once you identified which is the best alpha value, after identifying the best alpha value, once again you have to rebuild the model with the best alpha value. Whatever the output you have got here, using that one, again you have to rebuild. Once again you have to rebuild. Now this is the values. For the best parameter, again you are going to rebuild. Now this values, now save it. Now in the multiple linear regression, in the MLR model, what is the train accuracy, test accuracy? You are going to write, right? For this, default values are same and there is no hyperparameter tuning for this one. Now polynomial regression. For polynomial regression, you identify the degree is equal to 3 as the best one. And for that, train accuracy, test accuracy. Now lasso. Within the lasso, we identify the best one, which is nothing but alpha is equal to 1000. For this, train accuracy, test accuracy. Next, you are going to do the same way for ridge regression. And you will identify which is the best alpha for ridge also. For ridge, the best alpha is 1, assume. For that one also, you are going to calculate the train and test. Next, elastic net. Within the elastic net, which is the best alpha, you have to apply the grid set CV. And you have to identify the alpha value and lambda value. Both of them you have to identify. And once you identify the best values, again you are going to calculate the train accuracy, test accuracy. Now, total 5 different algorithms we are having: train and test, train and test, train and test. Which out of these all 5 algorithms, which are the good models you have to go? This is not a good model because linear assumptions has failed. This is a good model, neither overfitted or underfitted. This is a good model, neither overfitted or underfitted. Good model. Again, this is having some kind of problem. Assume some problem is there. Now, out of these 3, whichever is the best one, that you have to select and you have to share to the deployment team. Yesterday, I have told you, right? The same train data has to share to the ML algorithm 1, ML algorithm 2, ML algorithm 3. Like this, you have to share to everything and identify which is the best one. That finally you have to select only one model, one algorithm only you have to select for the given data. In this way, we will do the project in the companies. For the given data set, we'll try all the ways, and after applying all the different ways, which gives the best one, which satisfies the business requirements, that model will save that one and will share to the deployment team. Got the point? So now here, first we have to build the model with default parameters. First we have to build. We have to identify which is the best alpha value. I mean, hyperparameter tuning has to be done for that model. And after that, you have to rebuild once again with the best values. Similarly, ridge also. Ridge, I'm going to take default parameters. Default means inside that I'm not going to give anything. Automatical default. Now I'm going to apply the hyperparameter tuning. This time the estimators I'm going to take ridge. Earlier the estimator is lasso. Now this is ridge. Now within the ridge alpha values, I'm going to try always param grid. Remember, the param grid, whatever the param grid is there, that should be dictionary. Always your param grid should be dictionary. 100% it should be dictionary. Within the dictionary, the parameter name, whatever the parameter you want to check for everything. Here alpha is the parameter. Na? In your case, whatever the parameter is there, for that algorithm, whatever the parameter is there, that should be considered as the key. For which values you want to check, that should be as a list of values. 100% it should be list only. If you give any other values, it will throw an error. So parameter should, whatever the parameter you want to try and with what list of values you want to try, that you have to give. So if you remember in the polynomial regression, what is the parameter? Parameter name is degree. Yesterday, what we have tried? What are the values we have tried? From 1 to 10. That is 1, 2, 3, 4. That is nothing but range of 1 to 10. So here, if you are applying the same concept with respect to grid set CVMS, we have to take in this way. Is that clear? Now, so once again, you are going to apply the hyperparameter tuning for the ridge regression and you will identify which is the best parameters. What are the best parameter is there? using that best parameter, once again, you have to substitute and rebuild the model. Similarly, elastic net regression. From sklearn.linear model, import elastic net and fit on the X train, Y train and predict on the X train, X test and calculate this one. Apply the hyperparameter tuning. This time hyperparameter tuning is alpha and L1 ratio, both of them. And it is we are going to identify which is the best parameter. Alpha is equal to 10 with L1 ratio of 1 is the best combination, it seems. So what it is going to do, first it will try with 0.1 with 0.1, 0.1 with 0.5, 0.1 with 0.75. Like this, it is going to try for each of them. So this side 1, 2, 3, 4, 5, 6. So for 0.1, it will try 6 models, 6 different lambda 1 values. For 0.2, it will try 6. For next one is 1, it will try 6. For 2, it will try 6. For 3, it will try 6. For 5, it will try 6. For 10, it will try 6. Like this, 7 into 6, total 42 models are designed. Out of these 42 models, which model is best one, miss? Alpha with 10 and L1 ratio of 1 is the best one. That model, now using these two values, again you have to rebuild the model. Is that clear? Guys, yesterday you have taken the notes, right? Do you remember yesterday's class, whatever the notes you have taken in the Jupyter Notebook 1, we have to do the EDA. In the Jupyter Notebook 2, we have to do the data cleaning, data wrangling and train test split. And with that, the work of Jupyter Notebook is completed. Jupyter Notebook 3 is models, different types of models we have to take, where once the train test split is completed, the train data, whatever the train data is there, the same train data has to be sent to the ML algorithm 1. The same train data should be sent to the ML algorithm 2. Same train data should be sent to the, without changing the values. We should not change the values. Same to same has to be sent. If you are having any doubt, miss, you can check. Here, whatever the X train, Y train is there, I'm clicking on this. I'm printing the X train. If you want, you can check the X train values. So 169, 97, 31 records. Let us open the polynomial regression. Let us open the multiple linear regression. So in the polynomial regression, if I apply this one, okay. Now after this, I'm going to check with X train values. Whatever the X train is there, just let me open this X train. Same 169, 97, 31. In this also the same thing is there. Data I have changed after train test split. Did I change the data? Same test size of 0.3, random state of 42. Here also same test size of 0.3, random state of 42. Same data I have considered. Data was not changing. If you apply this multiple linear regression, go with multiple linear regression and check with respect to this. And now if you apply this X train, now you calculate for X train. Open the X train. Now same data. Any changes in the data? None of them is having the changes in the X train. Everyone are considered on the same. Test size of 0.3, random state of 42. In every case, it is same. Though it is in the different Jupyter notebooks also, the data is same because random state is fixed with one value, means data will not change. Okay. So now, whatever the data is there, train data is there, this train data I have shared to the ML algorithm 1. I have shared the same data to ML algorithm 2. I have shared the same data to ML algorithm 3. I have shared the same data to ML algorithm 4. I have shared the same data to ML algorithm 5. That is, first one is linear regression, polynomial regression, lasso regression, ridge regression, elastic net regression. I have applied the same data I have shared to everything. Within this, which is the best I have identified. Within this, which is the best I have identified. Within that only. Within the polynomial only, I have identified which is the best degree. That is not connected to others. Within this only, which is the best. Now, within the lasso, which is the best alpha? I have added, calculated. Within the last ridge, which is the best? Within the algorithm, within this, which is the alpha with lambda 1, lambda, alpha and lambda, both of them, which is the best I have identified. Now, within that, I have identified each of them, and overall, I have identified which is the best. Okay. For your easy understanding, let us assume for SRK, in the SRK batch, multiple students are there. Who is the best student? Who is the best student is the question. Who is the best student or who is the topper? This is the question. Or let us take like this. Who is the topper? Okay. Who is the topper? For batch 1. Okay. For batch 1, one student will be there. For that batch, in that batch, one student will be there. For every batch, one student will be there, right? In your batch also, one student will be there. In other batch, one student will be there. For batch 2, one student will be there. Now, this student, how I am identifying? Within that batch only. I am not comparing with other batches. I am comparing within that batch only. Who is the best student? Within batch 3, who is the best student? Now, overall, I required only one person. Miss, out of these 3, one person I have to select, right? That one. Okay. To be more simplified for you, state-wise rankers are there. State first, state, every state, one state will be there. If you go with the IIT exam is all India level. If you go with all India level, now every state, one ranker will be there. Top ranker. From Andhra Pradesh, one ranker will be there. From Telangana, one person will be there. From UP, one person will be there. From every state, one ranker will be there. What his rank is? State first rank. State first, state first, state first. Everyone says that state first. Total 29 states are there, means 29 states, 29 state first rankers are there. But all India first is who? Only one person. First, you are identifying the state first. Who is state first? Within that state first, you are identifying later all India first. Similarly, in the algorithms also same. Within that lasso, which is the best alpha, you are identifying first. Within the ridge, you are identifying which is the best. Within the elastic net, which is the best you are identifying. Out of these 3, which is the best, later you are identifying. Is that clear? So like that we have to do. This is called as a complete project. In the company, if you get a project like this, and if they ask you to, with respect to the relation between TVs, radio, newspaper versus sales, assume this is same data was given in the company. And they asked me to do the project. So I'm going to do first common thing, understanding the data, EDA, common. Data cleaning, I will try with different options and I will check with the multiple linear regression, which gives the best one. That data cleaning, I will fix myself. Once the data cleaning is also locked, the data is locked. Now I will try with multiple algorithms. Data is also locked. Random state is already locked. Test size is already locked. Data cleaning is already locked. Everything is locked. Now, which is unlocked is machine learning algorithms. Now, in the third Jupyter notebook, I will try with various algorithms. After applying all the algorithms, finally, I will select one algorithm. And that algorithm only, I will save the model. And that model, I will give to the deployment team. And they are going to deploy that one in the website or cloud or whatever it is. Whichever is the best model, that one only will be deployed. What about the remaining algorithms, sir? Dustbin. Just we have to throw into the dustbin. Okay. To the client, we are going to explain only the final one. Sir, night 1 o'clock, I have, from night 1 o'clock, I have done the work, sir. For example, tomorrow I will keep one exam. Okay. Assume there is tomorrow one exam is there. Example. There is no exam. Don't worry. Okay. Example only. Example, tomorrow there is an exam. Now, in the tomorrow exam, I will ask one of the student randomly selected and I will ask the questions. That is interview. I am going to interview that person. Now, this person, he will sit in front of me and whatever the question I ask, first he will say upward like this. Sir, I have studied, sir, but I am not able to recollect, sir. Sir, still yesterday night 2 o'clock, I have studied, sir. but I am not able to recall. Then what is the use? What is the use? For example, you are having with respect to your BTech percentage is 65%, assume. Due to unexpected reasons, due to the semester, during the semester exams, final exams only, you have got fever. It is a genuine exam, genuine only. Genuinely, you have got the fever and you are not able to concentrate on the exams. But government will not check all these things now. They will shortlist only with respect to whoever's score is greater than 80%, right? If I start discussing like this, every person will have their own reason. Every person will have, right? At the end, we can't listen all these reasons. We require only with respect to yes or no only. Similarly, in the company also, why I have told all these things means in the company, whether you have got the good model or not, they'll ask like this one. Sir, I'm trying this one, sir. I'm trying that one, sir. I'm trying this one. No need to say anything. Whether the project was completed or not completed. Yes or no. Answer is very simple. Sir, till night 2 o'clock, I'm trying the model, sir. But I am not able to get the answer. Then complete waste of time. There is no use. From the company perspective, from your perspective, it is valuable time. From company perspective, it is waste of time. Right? So just we are going to apply the various models on the single data and we are going to predict which is the best one. This is called as capstone project. The same thing we are going to do in the Kaggle. In the Kaggle also, they are going to share you one data set. And for that data set, you have to apply whatever you want. Whatever the way you want and whatever the things you want to apply. And finally, give me the best answer, which gives the maximum accuracy. Right? Every time remember, first we have to do the default parameters. First, we have to start with default. After that, we have to apply hyperparameter tuning. After that, we have to rebuild with the best values. Whatever the hyperparameter tuning values we have got, that values we have to identify. Then we have to stop that algorithm. With that, that algorithm is completed. Now we have to go to the second algorithm. For second algorithm, again default parameters. Again hyperparameter tuning. Again identify which is the best parameter for that algorithm. With that, second algorithm also completed. Now you go to the third algorithm. Third algorithm, again default parameters. Third algorithm, hyperparameter tuning. Third algorithm, again rebuild once again the model. That is third one. This is also completed. Now fourth one. Like this, how many are there? Everything you have to do the same way. Once everything are completed, you have to identify the best one. This is the first project. I have explained for a single data set, everything on the same. From Monday's class, we are going to start the classification algorithms. For each algorithm, I am going to apply on the single data set. Separate data sets I am going to select. So now what happens? For example, Monday, I am going to start with respect to classification. I'm going to start the classification algorithm, first algorithm, algorithm 1. For this, I am going to apply on the one data set. For algorithm 2, I am going to take a different case study. Different project. Completely, I am going to take a different project. Project number 3, I am going to select. This is project number 2. Now, algorithm 3, within the classification of algorithm 3, I am going to take the one more project, different project. Now, what you have to do is, for this data set, remaining 2 algorithms you have to apply. For this data set, remaining 2 algorithms you have to apply. For this data set, remaining 2 you have to apply. Like that, total 10 algorithms are there. 10 projects I am going to cover in the classification. 1 I will apply. Remaining 9 you have to apply for everyone. For every data set, remaining 9 you have to apply. Is that clear? Once you do like that, then you'll understand for each data set, we have to apply all the algorithms and how it is performing. Now, with that classification, if everything is done, means now you will be ready for taking the Kaggle exam, Kaggle competition.